The month of February is coming to an end. In ancient Rome, the end of February was the end of the year. And since Julius Caesar, we've been adding a day after the 28th of February every 4 years, the 29th. Why? Because the time we take to complete our orbit isn't 365 days, but 365 and a quarter. The Earth reaches the end of the 28th here. To complete the year, a quarter day is missing. The Earth continues on its journey, and since it began this lap a quarter day out at the end of the year, when it reaches the 28th of February, 2 quarter days are missing, half a day. A year later, it's 3/4 of a day, and after 4 years, 4 quarters. An entire day is missing. Every 4 years, to plug this gap between the Earth's daily cycle and its annual journey, we slip in the 29th of February. So every 4 years, we have a year of 366 days, a leap year, to let our planet leap the gap and stop our calendar shifting. This is achieved by the Julian calendar, introduced by Julius Caesar. If we didn't add the 29th of February every 4 years, March would begin 1 day earlier. After a century, we'd already have a month's gap between the calendar and the real seasons. We'd celebrate Easter in the winter and Christmas on Halloween, and the chaos would grow from century to century. So many thanks to Julius Caesar. But adding the 29th of February doesn't solve all our problems. Unfortunately, when the Julian calendar adds the 29th of February, it adds 38 minutes too much. At the end of the 16th century, we'd gained 10 extra days. So Pope Gregory XIII, a keen astronomer, removed these 10 days, and we went directly from the 4th to the 15th of October. To avoid meeting with the same problem again, he decided not to add a leap year to the last year of each century, 1700, 1800, and 1900. However, an exception is made every 400 years. Thanks to this fine-tuning, our Gregorian calendar will see us through the next 3,000 years. But in Orthodox Christian countries like Greece and Russia, the Julian calendar remained. That's why the Greek Easter is celebrated 13 days later. And the Russian Christmas too. Why 13 days when Pope Gregory only cut 10? Since Pope Gregory, the uncorrected Julian calendar has shifted 3 more days. In total, it's 13 days behind. Synchronizing our calendar with the Earth isn't an abstract formality. It's needed to link the universe with the real rhythm of our seasons. So if our calendar is properly adjusted, why does Easter hop about between March and April? The date of Easter doesn't just depend on the sun, but also the moon. Easter falls on the Sunday, which follows the first full moon of spring. Lunar calendars also exist, like the Islamic one. At the end of Ramadan, the time of fasting is announced by the first crescent moon, the day after the new moon. Synchronizing the cycles of the moon and sun is a very tough proposition. Since men began to try and measure time and establish calendars, they've been struggling with the problem. The oldest calendar we know is the prehistoric Temple of Stonehenge in England. Its axis points towards the rising sun on the day of the summer solstice, the 21st of June. But to mark the moon's progress, a complicated fan of axes was needed because the same positions are only repeated every 18 years. Even so, our ancestors could predict eclipses, where the sun and moon meet. They'd already succeeded in combining the solar and lunar calendars. On Earth, the need to measure time and predict the seasons came when man began to till the Earth. But the Earth isn't the only place where there's Earth. Our neighbors Mercury, Venus, and Mars are made of Earth too. They're what we call solid planets, Tellurian planets. We could walk on the surface of Venus if it weren't so very hot. One day, we'll certainly step out on the rocky terrain of Mars. But we'll never walk on Saturn or Jupiter. These great planets may have solid cores of rock or metal, but they're mostly made up of gas. What's more, the mass of Jupiter is 300 times the Earth's, and its gravity would crush us instantly. That goes for Saturn too, which is 100 times more massive than Earth. In the near future, our only chance of landing on another planet is Mars. But first, we have to take good care of the Earth, which is the only place in the solar system where we can live naturally.